Hello, yo, welcome back. All right, so let's continue from where we stopped. Now, this time around, we're going to be looking at the unit of measurement. All right, so now the internationally accepted, all right, or the standard unit of measurement in physics is known as the System International Unit, of course, abbreviated as SI unit. All right, so now we're going to be looking at the fundamental quantities and their unit, and that is what we refer to as the fundamental unit. So we're going to look at the three important fundamental quantities, right, which is mass, length, and time. So starting with mass, by dimension, the dimension of mass is capital letter M, all right? Okay, so mass, of course, is measured. The unit of mass is meter. The unit of, please pardon me. The unit of mass is kilogram, please pardon me, all right? Okay, so mass is measured in kilogram and abbreviated as kg. That is the SI unit of mass. Then length. Length is measured in meter. Time is in seconds. All right. So now, as I said, this is a system international unit. That doesn't mean that this quantities doesn't have other units, but in physics, this is the unit we use for these quantities. So let's look at the other fundamental quantities. Okay, let's look at electric current. Okay, and by the way, don't forget that the dimension of length is capital letter L and that of time is capital letter T. Electric current, capital letter I. Okay, so the unit of electric current is ampere. All right. Okay, then of course temperature. So the unit of temperature is Kelvin. Is Kelvin. All right, and of course we have the amount of a substance. Amount of a substance, which of course is measured in mole. Um, and the last but not the least, we have the luminous intensity. The luminous intensity, that is the intensity of light. Okay, so this one is measured in candela. Candela. All right. So these are the fundamental units. Okay, so please take note of them. All right. So how about the derived units? All right. So what we're going to be looking at is let's look at the derived units in terms of their dimension. All right, and of course, uh, let's look at let's go by. Okay, let's arrange it in a tabular form. So this column is the column for derived quantities. Then their dimension, of course, this we have a column. This column is the SI units. All right, so can we begin? All right, number one, speed, which of course have the same dimension with velocity. Okay, so what is the dimension of speed? We've already done this. Okay, speed or velocity, the dimension of speed or velocity is LT raised power minus 1. Okay, from this from the dimension we can also write the units. Okay, So we can derive the dimension from the unit. So already L_t raised power minus 1 is the dimension of speed. So in terms of unit, in terms of SI unit, length of course is meter, t is time, which of course is seconds, then raised to the power of minus 1, ms raised to the power of minus 1. All right. Number 2, we have the acceleration. This is measured in dimension as L_t raised to the power minus 2. So, of course, the unit L is m, that's mx raised to the power of minus 2. Okay, number 3, we have force. All right. So, force in terms of course, dimension is mass times acceleration, that is m, then multiplied by acceleration, which L_t raised to the power of minus 2. So let's look at the unit. The unit, of course, is m, mass is kilogram, that's kg, length is meter, then of course seconds square. Now, which of course is equal to 1 Newton? Right? So instead of writing this unit, this derived unit as kilogram meter per second square, rather we use 1 Newton. So the SI unit of force is Newton, abbreviated as N. Please take note of that. And of course, let's look at work. Work, we know that the dimension of work is ml squared, then t raised to the power minus 2. Okay, so the unit is derived as, of course, kilogram meter square, then of course per second square, which of is equal to 1 joule. Is equal to 1 joule. All right. So don't forget, we use this as the unit of work. What joule is the SI unit of work? All right. Number 5, we have power. Power is work divided by time. So the dimension is ml squared. Then of course t raised to the power of minus 3. So is the derived unit is kilogram meter square, then per seconds cube. So this is equal to watts. So as you can see, for these three derived quantities, force, work, and power, we use these units: Newton, joule, and of course watts. I hope that is one. So there are others, but let's talk about how to convert, just in case, as I said. This SI unit is actually the system international unit for these quantities. Okay, that doesn't mean that we don't have other unit for all these derived and fundamental quantities, but just in case the quantities expressed in other units other than the SI units, how do we convert them? Right? How do we convert other units to the SI units? So that this will bring us to another important subheading, which is the preface. Okay, so the preface to a unit. So this preface to a unit is actually tells us the conversion factor. Okay, the conversion factor. So what this the conversion factor is what we are going to multiply to a unit to convert it to the SI unit. All right, or to convert from SI unit to other unit. So it's all about conversion factor. So this preface is in terms of multiples. Multiples are the one that you convert by multiplying, all right, by powers of 10, by positive powers of 10, while the sum multiple is the one that you you convert by dividing or even by multiplying by negative powers of 10. Let's begin with the submultiples. All right. So let's look at the submultiples of unit. The prefix that defines the submultiples. Okay. What do I mean? Let's start with the submultiples. Okay, I'm going to start from Pico. Okay. So when a unit have this prefix, so let's Pico abbreviated as P. All right. So anytime the unit have this prefix P before the unit, this simply means that you are multiplying by 10 raised to the power of minus 12. That is what Pico represents. 10 raised to the power of minus 12. Okay. Example. Let's say you have 2 picometer. Okay. Or maybe you can use any let's say picofarad. Okay. That's the unit of capacitance. So for you to convert this, all you just need to do is to multiply the 2 times 10 raised to the power minus 12. So that is how you convert that. All right. So this is number 1. Number 2. All right. The next prefix is nano, abbreviated as N. Nano is actually times is 10 raised to the power minus 9, or you divide by, of course, or you do 1 all over, you divide by 10 raised to the power 9. Okay, it's still the same. All right. So of course, example, 2 nanocoulomb is equal to 2 times 10 raised to the power minus 9 coulomb. That's how you convert that. All right. So we can also proceed to micro. We can proceed to micro. The symbol for micro is mu. All right. So how do we do this? Of course, micro is 10 raised to the power of minus 6. Okay, please take note of that. We can go on and on. Let's look at a milli. Milli, small letter m. Milli is small letter m. This is 10 raised to the power minus 3, or you divide by 1000. Okay, or you divide by 1000, 1 all over 1000. For example, if you are being given 2 millimeter to convert to meter, all you just need to do is to divide the 2 by 1000, or you multiply the 2 by 10 raised to the power of minus 3. You've converted it. All right. So can we proceed? Then we now have the centi C. This is 10 raised to the power minus 2, which is the same as 1 all over 10 raised to the power 2, which is 1 over 100. All right. Okay. So, for example, 2 centimeter is equal to 2 all over 100 meter. Then we now have the deci. All right. The deci, which of course is C. All right. Is D, please pardon me. That's 10 raised to the power minus 1. Okay. And that's 1 all over 100. 1 all over 100. Or 1 all over 10, please pardon me. 1 over 10. Okay, so these are the basically the submultiples. All right, so how about the multiples? Let me actually increase this, or better still. Okay. Okay. I'm looking for, okay, here we go. All right, so how about the multiples? Now, these ones are multiples. Of course, you convert by multiplying by the positive powers of 10. Okay, let me start with giga. Okay, giga. That is capital letter G. This is of course 10 raised to the power of 9 multiplied by, not minus 9, 10 raised to the power of 9. All right, of course. 2 gigameter is equal to 2 times 10 raised power 9 meter. That's what that means. From giga, we have the mega, capital letter M, that's 10 raised power 6. Then we'll have the kilo, right? Okay, 10 raised power of 3. Okay, so take note of that. So anytime you are being asked to convert, all right, using these prefixes, these are the conversion factors. All right, so having known this, we're going to be looking at example on this conversion in the next video. So see you in the next video. Thank you very much.